This is page 92 of the Incredibles book. We'll be doing the whole problem here. This is a falling object problem. All right. Draw a picture that depicts the situation. All right. So what is the situation? We've got time t equals 0. A diver jumps from a platform that is 32 feet from the water with an initial velocity of 16 feet per second. So here's the platform. He's jumping off and diving down. So that's our image. Okay. So the position equation will be S of t equals, we're on planet Earth, so it's negative 16t squared. So this will be the beginning of every position equation on planet Earth, okay? And if we are not on planet Earth, they will either give you the equation or they'll give you the acceleration due to gravity. And they will emphasize the fact that you're not on planet Earth. Generally speaking, the questions will be on planet Earth, so don't sweat that part. All right, let's continue. They give us an initial velocity of 16 feet. So initial velocity is the next one here. So it's 16t. And notice it is positive, right? You're jumping up from the platforms. So you're moving away from the Earth. Hence, it's a positive velocity. And then we have, it's 32 feet from the water. So that's our initial position. And there it is. All right, so negative 16t squared is for everything on planet Earth. This is initial velocity, initial position. All right, now let's take the derivative. So v of t is the derivative of s. So we just do that. So it's negative 32t plus 16. And that's the velocity equation. And the acceleration is going to be the same for all of these. Because all you're going to do is take the derivative velocity. And on planet Earth, acceleration due to gravity is negative 32. Or this is in feet per second. So if it was metric, it'd be negative 9.8 meters per second. Okay, moving on. When does the diver enter the water? So remember, this is, position is off the ground or off the, I don't know, off whatever. Okay, water is considered ground level at this stage. Okay, I understand that that may be different, but we're basically going to assume the distance from something is going to be distance from this thing. So when does the diver enter the water? So basically, when is this equal to 0? So negative 16t squared plus 16t plus 32 equals 0. I'm going to divide by negative 16. Negative t squared minus t minus 2 equals 0. I'm getting t minus 2, t plus 1 equals 0. So t equals 2, t equals negative 1. All right. So we're going to reject a negative 1 because we're not going backwards in time. So when does the diver enter the water? After 2 seconds. Diver enters the water after 2 seconds. Okay, next one. What is this velocity at the moment he enters the water? So now we're going to use the velocity equation, which is negative 32t plus 16. And we just want to know what it is at t equals 2. So it's v of 2 equals negative 32 times 2 plus 16. So that's negative 64 plus 16 is negative 48. So I was following that. 48 feet per second. When does the diver reach his maximum height? Okay, when does the diver reach his maximum height? So let's talk about that for a minute. So the path the diver is following is pretty parabolic, right? So basically, you're reaching the maximum height when your velocity reaches 0, right? So what's happening is as you go up, your velocity is positive, but you're slowing down as you go higher and higher. At some point, your velocity is going to turn negative, right? Because then you're going to start heading towards the ground. So what is the number between positive numbers and negative numbers? And that number is 0. So we're going to find out when this thing is equal to 0, when the velocity is equal to 0. So we just say negative 32t plus 16 equals 0. And we get negative 32t equals negative 16, so t equals half. So when does the diver reach his maximum height? The diver reaches maximum height at t equals 1/2 seconds. Or you could just say after half a second. All right, what is the diver's maximum height? Well, we know when it happens, so all we're going to do is plug this into the position equation. The position equation is, so I'm just copying it here for convenience. It's negative 16t squared plus 16t plus 32, and we're plugging half into that. So it's s of half was negative 16 half squared plus 16 times half plus 32. So that's negative 16 times a quarter. Half of 16 is 8. So what's that? Negative 4, 36. So there's a maximum height, max height of 36 feet. What is the average velocity from the time he hits his maximum height to the time he enters the water? All right, so we're looking for average velocity. So we need to know what s of half is, which is 36, and what is s sub time he enters the water. He enters the water at t equals 2, so s sub 2, which is equal to 0. All right, so we're going to do s sub 2. So average velocity is going to be s sub 2 minus s sub half. So that's 2 minus a half. So s sub 2 was 0 minus 36, 3 halves. So negative 36 times 2/3. So what is that? Negative 24 feet per second. So that's the average velocity, negative 24 feet per second. And that's the end of page 92.